Now that we've seen not, nor, and NAND, and previously we saw or and AND, these are what we call logic gates. These are building blocks that we're going to use to build more complex digital functions later on in the course. Now, we're going to put these together, a lot of these in some cases, and it can get kind of tedious to draw all of those transistors. So in order to avoid that, we have some handy symbols that we can use in place of those transistors. Let's talk about those. The first is the symbol for a NOT. It looks like this. I have my input A on the left, and you can draw it the other way if you want as well, but typically logic diagrams flow from left to right. And on the right I have my output, which is the inverted value of the input. Now I've shown this as a bar. There's a couple of other ways that we can represent inversion. We can represent it also as a prime if we like, or we can put a slash in front of the A. So all three of these represent a NOT gate. Now let's talk about an OR gate. Here's the symbol for an OR. I'm going to draw a two-input OR. I have inputs A and B. Now you can extend this to other number of inputs as well. So I can have 32 inputs going into this OR gate. And my output is represented with a plus sign between them. Now, don't mistake this for addition. This looks like addition, but here we're representing the logical function OR. Let's now look at AND. And AND looks like this. Again, I assume I have two inputs, but I can have any number of inputs. And my output I represent as A dot B. And a dot we can also represent as multiplication. Again, don't get confused here. We're talking about the logical function AND. Now, just like with multiplication, sometimes we leave the dot out. So if you have two inputs A and B, and you see A, B, that also represents logical AND. Now, we're going to use these basic NOT, OR, and AND later on in the course when we create these more complex logic functions.